All right, this is section 5.3. We're going to talk about logs and natural logs. You guys have your calculators. Today's not really much about evaluating as much as it is moving stuff around. Part of your quiz is going to be rewriting things in either log form or exponential form. So it's not really what's the answer, it's how to write what we're looking at. You guys have seen this before. How do you know which one is in exponential form and which one is in logarithmic form? Exponential has a variable in the exponent, like Nunez just told us. And then Hayden says the other one says the word log. Do you guys see that? Yes or no? There is a relationship between these two things. They all have the same numbers or letters in them, don't they? You see how it says A, X, and Y? It's just a matter of where things go. When you're moving from one form to another, in logs, your A is little. In exponential, your A is big. It's the base. And then what do you notice the X and the Y do? They switch sides, okay? So we're going to talk about that. It makes more sense when we look at it with numbers. So if we have something like this, and it says, if you read the directions, it says, write the following equations in exponential form. What kind of a form are they in? Log. They're in log. So I told you, when you start off in log, the little number becomes your base, becomes the big one. So I'm going to write a big 10. And then think about this. 100,000 and 5 are going to switch places. If you guys forget which way to move stuff, think about this for a second. Would it make sense that I would move this here and this here to say 10 to the 5th power equals 100,000? Yes. Or would it make sense to say 10 to the 100,000 power equals 5? Yeah. Right? So a lot of these you can figure out, you can look at and be like, oh, well, that's just what makes sense. So don't get caught up on, well, the X has to move here and the Y has to move there. Just use your brains. This isn't terribly difficult. This says log 2 of 8 equals 3. So my little number is 2. That means it becomes what? Big. I'm going to write a big 2. And then am I going to write 2 to the 8th power equals 3 or 2 to the 3rd power equals 8? 2 to the 3rd power equals 8. And is that true? What's 2 times 2 times 2? 8. Make sense? All right, so if I go down here, oh no. I have negatives and I have fractions. Therefore, everything gets what? Super hard and complicated. Well, up here, guys, my little log number became the big base, yes? So what do you think happens here when I have a big base? It becomes the what? Little log. So I'm going to write log with a little 2. So what happens with -3 and the 1/8? Do they stay in the same spot or do they switch? They switch like this. So it says log 2 of 1/8, you can put it in parentheses if you want, equals -3. So think about that, guys. If I evaluated this like it says, what's 2 to the 3rd power? 8. If I have a negative exponent, remember that means fraction. So if I had 2 to the -3rd power, if I wanted to write that with a positive fraction, it would be 1 over 2 to the 3rd power, correct? When you put it up, when it goes up or down of a fraction bar, it becomes positive. So then that would give me 1/8. So over here has letters. That's okay. What does the 5 become? It's little because it starts off big, so it becomes little. And then what happens with R and S? They switch spots. They switch sides. So it becomes log 5, what? S equals R. That's just making sure you understand what stuff does, how it moves. All right, so if you start off with log and you have a little number, that little number becomes the big base. If you start with a big base, that becomes the little what? The little number in the log. Good. Okay, so say it says evaluate. That means figure out what the answer is. So look at this. Log 10 of 1,000. What that's saying is 10 to what power gives me 1,000? What's my answer? 10 to what power gives me 1,000? 3. So this would be 3. What is this question asking? Okay, log 2 of 32. But what is that really asking you? Because little 2 becomes what? The big base. So 2 to what power gives me 32? Everybody think. Just do it. 2 times 2 is 4, right? 2 times 2 is 4? Yes or no? 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. So 2 to the fifth power is 32. All right, look here. Uh-oh. It's a decimal. Does that mean it's going to be a big whole number or a fraction, you think? Okay, how could I make 10 into 0.10? Okay. Hold on. I could say a negative exponent. I like that. What's 10 to the first power? 10. What if I had 10 to the negative first power? What would that look like? 1 over 10, right? Which is the same as that. Good. Very good, William. Anytime you have a big number and you go to make it smaller, it's going to be a fraction or a decimal. What about this? Be careful with this. My little number is 16. So if I was going to evaluate this, my little number would become what size? Big. So 16 to what power is going to give me 4? I like the way you're thinking. 1/2, right? Does anybody remember what 1/2 is the same as? The square root. Very good. Very good. Good job, Belle. Very good. All right. A little bit of thinking involved here. Moving stuff around. Same exact thing here. It says use the definition of logarithms. So let's do this. Rewrite it first. It's in exponential power. So little 4 becomes big. And what happens with x and 2? They switch. So this is really 4 to the second power equals x. So x equals how much? 16. Good. All right. How do I rewrite this first? Little 3 becomes big. And then what happens with 27 and x? They switch spots. So this says 3 to what power equals 27? What's my answer? 3. Yep. On your quiz, you're going to have to do both the steps. You're going to have to write it like this. That'll be part of an answer. And then telling me what x equals is the second part. So when I come here, what is this going to look like when I rewrite it? Big X to the second equals 36. Now my answer would be x equals 6. Very good, guys. Y'all remember this from last year? Okay. And if not, you're thinking real well, so that's good. Oh, we're done with that one? Yeah. All right. We must raise a to the 0 power to get 1. Guys, remember this. Log a of 1 equals 0. Whenever you get log a of something equals 0, that means, look, if I were to rewrite this, it would be a. What would I do with 0 and 1? So it would be a to the 0 equals 1. What is anything raised to 0 power? Anything raised to 0 power is 1. All right. I know there's no numbers here, but I want you guys to look at this. Look at number 2. What do you see in number 2? Just on the left-hand side, what do you see? What do you notice? A little a, and a what? A big A. What do you think happens to those two? They cancel out. So your answer is 1. So if you had like log 3 of 3, what's your answer? 1. If you had log 7 of 7, what's your answer? 1. The reason why is this little 3 becomes the base, right? So it's 3 to what power gives me 3? What is it? 1. That's why they cancel out. What do you notice here? I have a little a and a big A, right? Yeah. Well, what happened a second ago when I had a little a and a big A? They canceled out and became what number? 1. That's why. So whatever this exponent is here is going to be the answer. You'll see in a second with numbers, it's much easier. What do you notice here? What are those of each other? Plus and minus are what of each other? Opposites, inverses. Division and subtraction. Division and multiplication are what of each other? Inverse. So look, guys, this is a big base raised to an exponent. Yes, that's exponential. But what's in your exponential? A log. So exponentials, write this down. Exponentials and logs are what of each other? Inverse. That's going to be super important when we do section 5.5 and we solve. Now, I know with letters, you guys are kind of like, wait, what? Let me show you with numbers, and you're going to say, man, can we have about 20 of those on our quiz? My answer will be no. Okay, look at this. If I were to rewrite this, my little 5 would become what? The big one. So 5 to what power gives me 1? 0. Anytime you have log base whatever, of 1, anything to what power will give you 1? 0. Every single time, guys. So here, what do you notice here? What do we have this? It's log 5 of what? What happens to those? They just do what? They cancel out. It becomes what? 1. Because what that's saying is 5 to what power gives me 5. What about here? What happens with my log 5? They cancel out. What's my answer? You guys like those? Yeah. What about this one? What happens with 5 log 5 to the 12th power? 5 log 5 does what? And your answer is 12. Yeah, we like those. So when you have log base whatever of 1, it's always going to be 0, and then everything else is just going to be nice and pretty. All right, logarithm with base 10 is called the common log and is denoted by omitting the base. Guys, if you look on your calculator, you have a button that says log. It does not say log with a little base 10 at the bottom. That is just assumed. All right, if I had log base 3, log base 6, that's a different log. You can't just put, if you had this, log 6 in your calculator, you can hit the word log and a 6. But if you had log base 3, 6, totally different answer. But if you don't see a little number here, you assume it's a 10. Everybody see that? So in a case like this, log 2, we'll do that in your calculator. Hit log 2 and see what it says. What is it? 0. What is it? 317?
No, 301.
No.
Okay.
I got error.
301?
Yeah.
Close the parentheses, see what happens. Okay. In your calculators, if you hit log, let's do it. Hit log 2. What do you get? 0.301, something like that. Okay. If you were to write this as log 100 equals 2. What's log 100? I'm going to put something like this on your quiz. They're not asking you to evaluate using your calculator. They're just asking you to expand it so you're writing it. What all this means, how would I rewrite this? How many zeros do you think I'm going to use? If I used 2 here, how many do you think I'm going to use here? If I used 2 here, how many do you think I'm going to use here?
3.
Yeah, so that's all that they want you to do here. Log of 1,000 equals 3. That's all they want you to do. Don't worry about evaluating. I'm not going to give you something like that just to rewrite it. Okay, ln and e. Guys, look on your calculators. Do you see your e to the x button that you've been using? Is it on the same button that has an ln on it? Yes. Those are what of each other, do you think? Inverses. So on your calculator, you have your ln button, and above it should say e to the x. So they're inverses of each other. Guys, it's the same exact thing as our exponentials. The rules are the same. But these are inverses of each other. Whoops. ln and e are inverses of each other. So if you have a question like this, it's the exact same thing that we talked about with our log and our exponential. ln and e are what of each other? So they do what? They cancel out. So my answer here is 8. Here's the tricky one. Can you rewrite this so I don't have a fraction? No, don't distribute anything. If I wrote it like this, does that mean the same thing? Yes? Yes or no? Okay, so now what happens with ln and e? So what's your answer? Always, they're inverse of each other. So here, anybody know? Do it in your calculator, see what you get. What'd you guys get when you hit ln 5? 1.609. That's it. If they ask you to evaluate a log, you guys have the ln button. ln and what are inverses of each other? E. That is really important to remember. We're going to do solving in 5.5, where you guys know how to solve. You've done solving a million times since you were in elementary school. But the only thing you have to remember is these are inverses of each other. Sound good?